Hello viewers, Mr. Nyati here, your presenter with another video this time around, proceeding to question we've done this, so we have done this, we've done this. We're now moving to question B4. Subscribe to my YouTube channel, like the video, share the video, and leave a comment in the comment section. This video we'll strictly look at this question. This one is a simple question, I must tell you. Why? Because in grade 9, no, in the grade 8-9 syllabus, there is a topic called materials and energy, and you must have looked at this temperature, change of state of matter. That is grade 9, but this is grade 12, and this was done by the GCE candidate. So now, may we try to dissect this question. What we have here is this graph showing the change of state, okay, of one substance. So let's read the question. The question says, figure B 4.1 shows the graph of solid pure substance changing its state of matter as it is being heated. So this substance is changing state. It is being heated, and then it is changing state from one state to another. Now look at this. Whenever you have such a question, okay, the slanting curves, they mean the state of matter, the definite state of matter. That is solid, liquid, and gas. So do we have all the three of them? We have 1, 2, 3. These three are the three definite states of matter. What do we mean? This is solid, A to B is solid, C to D is liquid, E to F is gas. Those are the secrets that you need to know. Then the flat curves, they mean the points. These are the constant temperatures at which this substance changes to another, changes from one state to another. What do I mean? This is the melting point, because we have a solid changing to liquid, and this is the melting point. Now, in this melting point, this is where we have the states of both solid and liquid. So here we have solid stroke liquid. We have solid stroke liquid. We have liquid. Again here we have liquid stroke gas, meaning that this is the boiling point. And then the other thing I need to explain is that, as you can see, it takes about 5 to 10 minutes, okay? 5 to 10 minutes, meaning it takes 5 minutes for this to begin to rise, okay? So now, at this point, what is happening is that there is energy here, the heat energy is being used to weaken the forces of attraction holding the molecule in the solid state. Okay, and again at this point you have the forces of attraction being weakened by the heat. Okay, that's why it is constant. So it is being weakened. Those forces of attraction are the ones holding the molecules in liquid state so that it can be changed to gaseous state. So those are some of the things that you need to know. Okay, so now let's go to the questions. So we can say that A to B is solid, B to C is solid stroke liquid, and again this is melting point. Then you have C to D liquid, okay, and then D to E you have liquid and gas, and then this is the boiling point, and then E to F is gas. So if a question asks to say what is the melting point, it's 10 degrees Celsius. What is the boiling point? It's 40 degrees Celsius. Okay, I hope that is helpful. All right, so now we move forward. The first question, what does it state? So maybe just to highlight what we are seeing on the question, this is what is there. You have this, pardon my drawing here, you have this, you have that. So this is A, B, C, DEF. Okay, so this one we have 10 degrees Celsius, this one we have 40 degrees Celsius. Okay, so this one is the boiling point, this one is the melting point, and then what else can we say? This one is solid, this one is solid stroke liquid, this one is liquid only, this one is liquid and gas, and this one is gas only. That's what it means when we are to explain more on this one. So now let's go to the questions. What do the questions say? What is the boiling point of the substance? The boiling point of the substance is 40 degrees, because we're looking at the last curve, flat curve, so it is 40 degrees Celsius. We move on to the next question. Before we move on to the next question, we highlight the answer. This is the answer. The boiling point is 40 degrees Celsius. Okay, I hope it is making sense. Move on to the next question. At which temperature will the substance exist both as a liquid and a gas? Okay, at which we know that at this point it is solid and liquid, here it is liquid and gas, so the temperature is still 40 degrees Celsius at that temperature. Okay, so we move on to the next answer, which is still 40 degrees Celsius. So we move on to the next question. Next question asks to say, state one difference between boiling and evaporation. So there are a number of differences, and I've decided to just tabulate them or put them in a table form so that you can be able to choose which one you think is the best for you. So evaporation and boiling, these are the differences. Okay, these are the differences. So you have evaporation taking place at any temperature. Evaporation takes place at any temperature. You leave water under the sun, that is not boiling, but the water will still disappear. That is evaporation. And boiling on the other side, however, boiling on the other side takes place at a definite temperature. You can choose this difference if you like, because the question demands only for one difference. The other one is that evaporation takes place on the surface of the liquid. Okay, it's just on the surface of the liquid, not throughout the liquid, while boiling takes place throughout the liquid. The other difference is that there are no bubbles observed, while in boiling bubbles are observed. The other difference is that evaporation takes place slowly, while boiling takes place slowly. So here what I meant was evaporation. In evaporation there are no bubbles observed or formed, while in boiling bubbles are formed. So those are some of the differences which I thought I should put here, and then you choose just one, because this question there is only one mark allocation. You choose only one difference. Okay, we go to the last question. What happens to the heat supplied at points where there is no increase in temperature? In other words, at flat caves, what happened? Like I said, this is where the heat is used to weaken the forces of attraction holding the molecules in solid state or liquid state. That is exactly what is happening. So this is the answer here. The answer is saying that, because it is asking what happens to the heat. The heat is used to weaken the forces of attraction holding the molecules in solid state or liquid state. Why are we saying only solid and liquid state? Because those are the only two constant or flat caves. These are the only two flat caves. So meaning that this is solid state. So for this to change to liquid state, the heat is being used to break down the forces of attraction. At this point also, the heat is being used to break down the forces of attraction holding the liquid in liquid form, okay, so that it can be changed into gaseous form or gaseous state. I hope this video was helpful and you'll be able to leave a comment. Bye-bye.